Breaking news, Malaysia representative for M3, Todak, have defeated by the RRQ Hoshi, the representative of Indonesia. This is because... Hello? What do you mean this is the wrong... Assalamualaikum warahmatullahi wabarakatuh. Sorry for the interruption. Today, I, representative of Group E, Muhammad Syahid Muhammad Yassin from the AA1C, will introduce you to the presentation of series and parallel circuit. So firstly, we need to determine the color code of the resistor that we need to use. So my group have decided that we will use 1 kilo ohm, 2 kilo ohm and 2.2 kilo ohm. So the color code for those resistors are, for 1 kilo ohm is brown, black, red and gold. For the 2 kilo ohm is red, black, red and gold. And for the 2.2 kilo ohm is red, red, red and gold. After we determine the value of resistor 1K, 2K and 2.2K, next we should calculate the total resistor, which is 2K times 2.2K divided by 2K plus 2.2K. This is because 2K and 2.2K resistor are parallel to each other. So after we calculate that, simply just add 1K and you will get 2.0476 kilo ohm. After doing so, we simply need to calculate the total current, which is 10 volt divided by 2.0476 kilo ohm, and you will get 4.884 milliampere. That is the total current. So to calculate voltage at R1, we simply use Ohm's law, V equals to IR, and put I total and the resistor value into the formula, that which means 4.884 milliampere times with 1 kilo ohm, resulting to 4.9 volt. So next, we need to find the voltage that is at R2. But before that, we need to find the current that is flowing through resistor 2, which can be done by using current divider rule, which is 2.2K divided by 2K plus 2.2K times with 4.884 milliampere I total, which is 2.5583 milliampere. But sir, why do we use 2.2K? Because current divider rule explains that if you want to find the current at R2, you need to use the resistor at R3. After we determine the current, we simply multiply it with 2K and you will get 5.12 volt. It's the same with VR3. We just flip the resistor, 2K divided by 2.2K plus 2K times with I total 4.884 milliampere, we will get 2.326 milliampere times with 2.2K, which result in 5.12 volt as well. So that's all. We found the V1, V2, V3 and I1, I2, I3. So next, I will let Roystin to show us the drawing and the measured value.
Hi guys, my name is Roystin. So today I'm going to show you how to draw a schematic diagram for series parallel circuit. So guys, before we construct any circuit, we have to know how to draw the schematic diagram for series parallel. So as you guys can see, this the supply is set to 10 volt. So all you have to do is just draw, this is for the supply 10 volt, and a normal series circuit with two resistors. For this task, our resistor that we are going to use is for R1 is 1K ohm, R2 is 2K ohm, and last R3 is 2.2K ohms. So this is R1, so it's gonna be 1K. This one is R2, 2K ohms. So because of we are going to construct a series parallel circuit. So all we have to do is just add R3, which is this way. So label it with R3 2.2K. So guys, now you know how to draw a schematic diagram for the series parallel circuit. So now let's move on constructing the circuit. So now I'm going to show you how to construct a series parallel on a breadboard. So first of all, here you have 3 resistors, which is the value is for this one is 1K, this one is 2K, and this one is 2.2K. So all you have to do is you are going to take 1K resistor and put it in your breadboard, as you guys can see. Next, we are going to take this resistor, which is 2K ohms, going to put it like this. Same goes to this one, which is 2.2K ohm resistor. So the reason being why these two resistors is the way that it put like it, because this is parallel. We have to prepare our jumper so that we can connect it in our circuit. So this is our USB supply. Before that, we are strictly not allowed to open the supply yet because it may cause a shock incident. Alright, so first of all, this is our positive. We connect it here, and we use another jumper to connect it from R2 to R3, and another jumper at below. Last but not least, another jumper. So you have to use. So last is our negative supply. Now we are going to measure it with our analog multimeter. So we have to set it to 10 volt, which is DC volt. The analog multimeter is set to 10 volt. So our supply, we have to set it to 10 volt. Alright, so now we are going to measure voltage drop through R1, which is resistor 1. So the reading is 4.9 volt for the VR1. For our second resistor, which is 2K ohms, we are going to find the reading is 5 volt. Third resistor, which is 2.2K, is same as the resistor 2K ohms, which is 5 volt. So now we are going to measure the current through all the resistors. So now the analog multimeter is set to 25 milliamp DCMA. First, when it comes to measuring the resistor 1, because we're going to find the current through resistor 1, we have to unconnect this, and we have to connect it to positive probe from the analog multimeter, and the negative will touch to the top of the R2. So the reading is 5 milliampere. Now we are going to measure I2. So what we're going to do is we are going to replace the bottom of the R2 with another jumper. You just have to connect the negative probe to the jumper wire and the positive probe to the resistor, and the reading will be 5 milliamps. So because of this R2 and R3 is in parallel, the reading will be the same. So I'm going to show you what exactly I mean. Same with R2, just have to replace the R3 with another jumper, connect it to a negative probe. The positive probe will be connected to the bottom of the R3, so the reading will be 5 milliamp.
Hi, my name is Ijayuan. Today I want to explain about arrow for voltage and current. First, for arrow V1, we take the 4.9 minus 4.94 and then 0.04 divide 4.9 and then 0.082 multiply 100%. Then we get the 0.82%. Secondly, for V2, we take the 5.12 minus 5 and then 0.12 divide 5.12, then 0.023 multiply 100%, and then we get the 2.34%. Thirdly, for V3, we take the 5.12 minus 5 and then 0.12 divide 5.12 and then 0.23 multiply 100%, and then we get the 2.34%. Next, for arrow current, we take the 4.884 minus 5 and then 0.116 divide 4.884 and then 0.024 multiply 100%, and we get 2.38%. Second, we take the 2.56 minus 2.5 and then take the 0.06 divide 2.56 and then 0.023 multiply 100%, then we get the 2.34%. Lastly, 2.33 minus 2.5 and then 0.17 divide 2.33, then 0.073 multiply 100%, and we get the 7.3%. Okay, this is the error.